In this section, we're going to work with linear equations in slope-intercept form. So in the previous section, we learned how to write in slope-intercept form, and now we're going to use these equations. So we're going to learn how to write the equations of line by using points on a line, which we have done in a limited way. We used points where one of the point was the y-intercept. But what if we don't have the y-intercept? So again, the vocabulary is the same vocabulary we had in the last section: y-intercept, slope, and slope-intercept form. So how do I go about doing this when they don't tell me the y-intercept? First, I find the slope. That's my first step. When they give me 2 points, I can calculate the slope. Then I need to find the y-intercept. And what I can do is I can take the slope and the coordinates of a point, right? And I can plug them in to the equation y equals mx plus b. Okay, so if I have the slope and I have y and I have x, then I can plug these items in and find b. Okay, so let's take a look at how that goes. So they've given me the point and the slope. So y is equal to mx plus b. I know that y was 1, my slope is 2, x is 5, and what's left is the b. So I'll have 1 is equal to 10 plus b. If I subtract 10 from either side, negative 9 is equal to b. Once I know my slope and my y-intercept, then I can write my equation. Y is equal to 2x minus 9. Okay, let's do that in a slightly different scenario. Here they didn't give me the slope, instead they gave me 2 points so I can calculate the slope. So my slope will be equal to y2 minus y1 over x2 minus x1. So 9 minus 2 is 7, 4 minus 3 is 1, so my slope is 7. And then I can take a point, either point. It doesn't make any difference. You should use whichever one you want. So I know that I have y is equal to 7x plus b, and I'm going to plug in x and y. So y was 2 when x was 3. So 2 is equal to 21 plus b. If I subtract 21 from either side, negative 19 is equal to b. If I write the equation, y is equal to 7x minus 19. Well, this might make you wonder, well, what would have happened if I'd used this other point? And let's go ahead and do that. Y was 9 when x was 4. So 9 equals 28 plus b. And if I subtract 28, I get negative 19 is equal to b. I get the same thing. So I still get y is equal to 7x minus 19. So it doesn't matter which point you choose. You should pick whichever one looks easiest to you. As we go through, we want to remember that when we think about our slopes and all the different ways that we might write the equation, so they can give me the slope and the y-intercept. That's what we've learned so far, right? The slope is m and the y-intercept is b. They can give me the slope and a point, so I use the slope and the x and y coordinates within here to find b, and then I rewrite the equation. Or they can give me 2 points where first I calculate the slope, and then I do the same things I did in this scenario where I take the slope and the coordinates of a point to find b. So these are the ways we've learned so far. Here's a scenario where I have a gym membership that costs $33 per month. Remember, $33 per month. This is a rate of change. This is going to be my slope. After an initial membership fee, I paid $228 after 6 months, right? This is going to be y, and this is going to be x. Okay, so what they've given me is they've given me slope and a point. I know that when X was 6 months, Y, my total cost, was 228. Write an equation that gives total cost as a function of the length of the membership. Find the cost after 9 months. Okay, so first, identify the rate of change in the starting value. Okay, I haven't been able to find the starting value, but I know that my slope is $33 per month. Find the change in the starting value. So that's what I'm going to have to do. But I do know that I have an ordered pair, 6, 228, from this information here. I could write a verbal model and then write an equation. I'm just going to actually go straight to writing an equation because we've done this before. We know we're using y equals mx plus b. Y was 228. Slope is 33. X was 6 plus b, right? Remember, I'm using y is equal to mx plus b. When I have 6 times 33, that's going to be 180 plus 18. That's going to be 198. And when I subtract 198 from either side, I'll get that b is equal to 30. Okay, find the starting value. Well, that's the starting value, $30. Okay. If I write the equation, y is equal to 33x plus 30, and then evaluate the function to find this total cost after 9 months, y is equal to 33 times 9 plus 30. Well, 33, let's go ahead and move this up so I have a little extra room. 33 times 9, 3 times 9 is 27, so that's 270 plus 27, that's 297 plus 30. So y will be equal to $327. Okay, let's take a look at another problem like that. In BMX racing, racers purchase a 1-year membership to a track. They also pay an entry fee for each race at that track. Okay, so if I paid a total of $125 after 5 races, this is an ordered pair. When the number of races was 5, the total cost was $125. A second racer paid $170 after 8 races. That's also an ordered pair. So the first thing we want to do is we want to go ahead and find the rate of change so that I can tell how much do they charge per race. Well, it's going to be 170 minus 125 over 8 minus 5. 170 minus 125 is 45, and 8 minus 5 is 3. So the slope is $15. So it's $15 per race. Right? Remember, these were dollars, and these were number of races. So I come out with dollars per race. If I want to know the starting value, I don't know that right now. So I'm going to go ahead and I'm going to use the y is equal to mx plus b. And I know that y was 125 when, y was 125 when x was 5 plus b. Sorry, I erased some of that. So 125, 5 times 15 is 50 plus 25, which is 75. Right? And 125 minus 75 is $50. So $50 is equal to b. Write the equation. y is equal to $15 per, $15 per race times the number of races plus $50. Okay, and that's working with, again, using slope-intercept form equations.